Hello, my name is Annie Tran. This is an introductory video for the Advanced Biochem Sections 1 and 2 playlist in our YouTube channel. This introductory video helps you, the viewer, understand the overall purpose of this research and what each presenter presents in their videos under this playlist. The topic is to develop a novel drug to overcome the drug resistance in existing FDA drug targets of tyrosine kinase inhibitors for treatments in cancers through virtual screening and enzyme kinetic inhibition assay. The purpose of the project, the aim. The research plan aim is to find novel drugs to overcome drug resistance of existing FDA drug targets for tyrosine kinase inhibitors through computational methods like virtual screening and experimental methods like enzyme kinetic inhibition assay for cancer treatment. When it comes to treating cancers, it is crucial to prioritize the discovery of innovative drugs that can effectively address the evolving nature of new strains and mutations. Drug and cancer targets for tyrosine kinase inhibitors. These are the various drug targets that are covered in Advanced Biochem playlist for sections 1 and 2. Each presenter individuals are assigned a drug target and have to gather a basic understanding of what it is, such as the table mentioned in this presentation, like existing FDA drugs, key mutants, and cancer targets to compare to their assigned drug target. Here is the drug inhibitor workflow computationally and experimental. In the computational side, tyrosine kinase protein structure, PDB-ID, and the FASTA file of wild-type NCB-ID and mutants is gathered for multiple sequence alignment and homology modeling. Then it goes through high-throughput glide XP docking. Same way where the FDA drugs and the zinc-15 drug-like library of 17 million compounds go through lag and pret, and they also go through high-throughput glide XP docking. Then through this whole process, the top compounds are selected for wild type for each of the mutants. And then overall, they examine the protein ligand interactions and docking scores. And then the experimental side of the whole workflow shows the enzyme inhibition assay, which is the final step of this whole workflow of the drug inhibitor side of the research. Enzyme kinase inhibition assay. The top compounds tested are using the tyrosine kinase assay kit to measure the activity for screening and profiling applications using the ADP glow as a detection reagent. The result shows a luminescent signal that correlates the amount of ATP that is inversely proportional to the amount of kinase activity. The luminescence would calculate the percentage of inhibition that is plotted by the concentration of the calculated IC50, which is the amount of drug is needed to inhibit the biological activity by half. The overall goal of the assay is to find the IC50 of the drugs against the mutant variant of the kinase. The overall conclusion. The expected results should show the FDA approved drug and should have the same as the IC50 like the literature to validate results in the study. The FDA drug should show that there is a higher IC50 when it comes to the mutant enzyme to prove the mutation that can cause drug resistance. The experiment can be proven successful if the inhibitors of the IC50 is shown to be lower than the current drug on the mutant enzyme. It shows that a compound has potential to enter biological testing for next generation cancer treatment. So the overall process, this is what the presenters are assigned to get the results and what the results should be expected. I hope this presentation helps you overall understand what the purpose of the research and what each of the presenters are presenting in their videos. Have a great day.